Hello class, Mr. Stemple here, and today we're going to talk about beams, particularly I-beams, hollow beams, and solid beams. So let's jump right into it. Today we're going to learn about why I-beams or hollow beams are more commonly used than solid beams. And your assignment for POE today is to build your own I-beam and test it. Here's my I-beam. I built it out of cardboard. You can build it out of whatever you want. You could also, if you want, build a solid beam. Here's my solid beam. Built that also out of cardboard. Also, your assignment for POE is to take notes on the equations for deflection and moment of inertia. And your IED assignment is to draw a cross-sectional view of your I-beam with dimensions. So here's my cross-sectional view of my I-beam with dimensions. Just like that. Okay, so now we know what we're going to be doing for both POE and IED. Let's talk about it. So the definitions that we're going to cover today, we'll start with beams and columns. When we talk about beams, we're talking about horizontal spans between columns. Columns are the vertical pieces that go up and down, and beams are the ones that span between the columns. And you can see those in a lot of places. Here's some pictures of bridges, of a bridge and one of a building. So this bridge has columns that go up and down. Those are things that go from the water to the top. And then the beams are spanned in between the columns. Now, it doesn't make sense to have columns everywhere. So you want to have beams that are structurally sound enough, strong enough that they will span between the columns depending on what it is that you're building. And if you look at this building over here, these beams over here are made out of concrete, and they span also between the columns. And beams have a particular function. Their function is to hold whatever load is supposed to be on the building or the bridge or whatever, so that it stays stable. So deflection. Deflection is something that happens when the load on a beam causes it to bend slightly. So whatever force you put on that beam may have some effect on it and cause it to bend a little bit. Some deflection is acceptable in most applications. It's why when you drive across a bridge, you feel it shaking a little bit. That's deflection. There's always a trade-off between deflection and cost. Obviously, you could build something that's huge, that costs a lot of money, that has very little or maybe even no deflection when you jump up and down on it or drive across it. But there's always a trade-off in that there can be a little bit of deflection based on the cost. So as good engineers, we want to minimize both the deflection and the cost. And so let's see some common beam designs. There's a solid beam, here a hollow beam, an I-beam, and an H-beam. And they have different functions and they have different shapes, obviously. So this is part of your IED assignment. I want you to draw one example of each of these four types of beams: solid beam, I-beam, hollow beam, and H-beam, and you can see what they look like right here. So let's talk about the formulas that we use when we're talking about beams. The first one is a deflection formula, and there it is right there. You've seen this before back when we did the beam deflection exercise where we were all standing around on beams and jumping up and down on them. You've seen this equation before. The maximum deflection is the force that's placed on a beam multiplied by the length of that beam cubed, and the length of the beam again is the distance between the supports, and that's all divided by the number 48 multiplied by the modulus of elasticity, which is that big number that you calculated when we did that lab, multiplied by the moment of inertia, which is the other one that we're going to talk about today. And the moment of inertia has to do with the shape of the beam, the size of the beam, and whether or not it's hollow or solid. So when we compare deflection of a beam, and that's what we want to do as engineers, how much is this beam going to deflect as opposed to a different beam, we want to compare, in this example anyway, the same beams of the same length and the same material so that we can compare the deflection and have a good comparison. Right? So today what we're going to be comparing is the differences between a solid beam and an I-beam made out of the same material. So if it's made out of the same material, it has the same modulus of elasticity. If it's applied the same force, then it has the same force F. And if it's the same length between the spans, then it has the same L factor. So if we look at that and we don't worry about any of those things, we can see that the only thing that matters is the modulus of elasticity, which is based on the size and the shape of the beam. So if the beams are of the same material, span the same distance, and have the same force applied, the only factor that determines anything, that determines deflection, is the moment of inertia. So let's talk about then moment of inertia and how we figure that out. Remember when we did the lab again, when we did the thing where we were spanning between the beams, it was PLTW 212, so you can look on that on the web and see what we did there and what some of those definitions were. We calculated the moment of inertia based on whether or not the beam was standing on its edge or standing on its side. And we were able to calculate different moments of inertia. In the next lesson, next week, we're actually going to do some of those calculations. But for this week, what I want you to do is to draw those pictures and have taken some of these notes. So for this week, you're going to turn in the build of your I-beam. So build your I-beam and test it. Take notes on the equations and stuff that I just looked at. So those deflection equations and the moment of inertia equations. And to draw for IED, I want you to draw a cross-sectional view of your I-beam with its dimensions and draw examples of solid, hollow, and I-beam and H-beam cross-sections. So that, once again, that looks like this in your notebook. Once you get all that put together, you can turn it in the usual ways. You can take a picture of it and upload it into Canvas, or you can log on to one of my conference calls that I have every day and show me what you've done. Good luck, and I hope to see you all in my conference.